Hello everyone, I am T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. In this lecture video, we are going to discuss about the title Test of Hypothesis. From this, we are going to discuss about the t-test. First, what is t-test? So t-test is a statistical test that is used to compare the means of two groups. It is often used in hypothesis testing to determine whether a process or treatment actually has an effect on the populations of interest or whether two groups are different from one another. So the test can differ into two groups using t-test. The null hypothesis H0 is that true difference between these group means is 0. The alternative hypothesis is that true difference is different from 0. When do use a t-test? A t-test can only be used when comparing the means of two groups. What type of t-test should use? When choosing a t-test, you can need to consider two things. One is whether the groups being compared come from a single populations or different populations. Second one, whether you want to test the difference in a specific direction. So the comparisons of a statistical t-test to test the significance of a mean sample, if it is less than 30, then we apply this t-test. The test statistics is calculated from x bar minus mu divided by s into root of n minus 1. What is x bar? Is a sample mean. Mu is population means. So the s square, that is a variance, is 1 by n minus 1 into sum of x minus x bar the whole square. Follows t distributions with the n minus 1 degrees of freedom. Why it is? There are n data, one person is taking the test, so except that one person, the degrees of freedom is n minus 1. So conclude that if the t value is less than the tabulated value at n minus 1 degrees of freedom, the null hypothesis is accepted. Otherwise, it is rejected. Now we are going to discuss a small problem from this. A type of insecticide is filled in packs using machines. A random sample of 10 packs were selected and their weights in kilograms are given below. So it is 50, 49, 52, another is 44, next pack has 45 weights and 48, 46, 45, 49 and 45. These are all the given data. Can you assume this sample be taken from the population of mean 50 kilos? So that's a question. Okay, now we solve that. First we form the null hypothesis. Null hypothesis H dot, that is the population mean is 50. That means the average weight of filled bag is 50 kilos. What is alternative? It is not 50 kilos. So levels of significance is 5%. So okay. So in this t-test, we need what is x bar and what is mu and then what is a variance value. So the given data all are in x. So x is 50, 49, 52, 44, 45, 48, 46, 45, 49, 45. So the total value of samples is 473. From this, we calculate what is the average. So after taking average, that is 473 divided by, there are 10 data are given, so divided by 10. So we get it is 47.3. It is average value. So now we calculate what is x minus x bar the whole square. So 50 minus 47.3 and its whole square. The value becomes 7.29. The next data is 49. The difference from the mean and the square is 49 minus 47.3 the whole square. It becomes 2.89. Likewise, 52 minus 47.3 the whole square is 22.09 and so on up to we get to 45. Final is 45. It subtract from the average. Subtract in the average is 47.3. So 45 minus 47.3 in the whole square is 5.29. So what is the sum value? Sum of all these values is 64.1. Okay, so now we calculate what is the variance, that is s square. The formula for variance is 1 by n minus 1 into sum of the deviation square of the average from the each value. That is 1 by n minus 1 into sum of x minus x bar the whole square. Already we calculated x minus x bar the whole square. It is 64.1. There are 10 data minus 1, that is 10 minus 1 is 9. So 64.1 divided by 9, the value becomes 7.12. So what is t-test? T-test formula is x bar minus mu divided by root of s square by n. So here the x bar, that is sample mean average is 47.3, and our observed mean, that is the population mean, is 50 divided by root of 7.12, that is s square, divided by number of data is 10. So after reduce that, the value become minus 3.2, but we consider as a positive value of t-test, so it is plus 3.2. So it is calculated value. Now the tabulated value for n minus 1 degrees of freedom, that is 10 minus 1 is equal to 9 degrees of freedom, from the t table at the 5% level, the value become 2.212, right? Since this calculated value is greater than the table value, so because our calculated value is 3.2, but tabulated value is 2.262 something. Since the calculated value t is greater than table value, therefore the null hypothesis is rejected. If always the calculated value is less than the table value, then we accept the H naught. But in this situation here, the t value is greater than the greater than the table value. So we reject the H naught. That means our conclude that the average weight of the bags is not 50 kilograms. Next we move to one more problem, is that a soap manufacturing sales saves through retail shops. Before advertisement, the average sale of soap is if in a soap is 140 dozens. After advertisement, a random sample of 26 soaps is taken, and the mean and standard deviation is 147 dozens and 16 per respectively. So can we say whether this advertisement is useful? So from this data, we give the conclusions for this. So what are given? The number of data. The number of data is 26 soaps, and the average says is 146. The dozens, that is a value becomes 16. Okay. So what is null hypothesis? The sample is 140. So whether the advertisement, if it is so, the advertisement is successful. So the population's average is 140 dozens. There is no increase in sales soap by advertisement. That is our conclusions. Alternative hypothesis greater than 40 dozens. So level of significance at 5% level. Okay, if I hear it, computation t start 6 as usual, it is x bar minus mu divided by s into root of n minus 1. Then put all the value here, it is 2.19. So the tablet value of t for 26 minus 1, that is equal to 25 degrees of freedom at 1% level. So the value become 2.060. Since the t value is greater than 2.06, therefore we reject the H naught, because the calculated value is greater than the table value. Therefore we reject the H naught. So we conclude that the sales of the soap would be increased through advertisement. And the third one, 10 individuals are chosen at random from the normal populations, and their heights are found to be 63, 63, 66, 67, 68, and so on inches. Test if the sample belongs to the populations whose mean height is 66. At 5% level value is 2.62 for 9 degrees of freedom, because there are 10 data. So 10 minus 1, 9 degrees of freedom. Now we test the sample belongs to the population whose mean height is 66 inches. So as usual, we take our number of data is 10. The average value is 67.8. So subtract each data. Subtract 67.8 from each data, and its square value we calculated 23.04. 63 minus 67.8, the whole square value is 23.04. Likewise, we get 71 minus 67.8, the whole square value is 10.24. And finally, we have what is the sum of the value, it is 81.6. Then S square we calculated is 9.066. The null hypothesis is 67 inch. The population, the height, average height is 66 inches. We check it. So the t-test is x bar minus mu divided by s into root of n. So we get 1.89. At 5% level, the degrees of freedom value is 10 minus 1, 9 degrees of freedom. So the value becomes 2.62 since the table value is always greater than the calculated value. That is, the t is always this t value, that is 1.89 is less than the table value. Therefore, we accept our H naught hypothesis. So it's concluded that the sample has drawn from the populations whose mean height is 67 inches. Thank you.